what we have to do, we have to consider it is not symmetric, right? The point is not symmetric about this. So what we are going to do, and it is a continuous charge distribution. So I will draw it again. Okay, so here, so this one I have drawn. See, point charge plus minus, this I am doing it. It is a thin, along the line only the charge will be distributed. But for diagram purpose, I am drawing like this, clear? So it is a thin thread. In the thread, the charges are there, okay? So that's how you should imagine. So here, the point P is here. So this is my perpendicular distance. Now what I am going to do, I have to consider, because it is a continuous charge distribution, no? So if the total charge is Q and the length is L, then lambda is what? Q by L. Now I am going to take what? A small element dl. Okay? Small element dl at a distance L from this perpendicular. Clear, ma? Now, what is the charge in this dl element? dq is the charge. So immediately what I will write? Lambda is dq by dl. So dq can be written as lambda into dl. Correct? Last class itself we have seen. Any doubt? You tell me. Now what is the angle this dl makes with the point P? So if I just connect this. So this is with respect to the perpendicular distance. Let me take it as phi. Okay. So this will be what? This is a small angle which is nothing but d phi. Correct? This phi can vary between what, ma? Here from this distance to this distance it can vary, right? So phi you can take from anywhere to anywhere, right? From this point to this point the angle can vary. Correct? Any doubt in this? You tell me. Now, due to this small element, there will be an electric field at the point P. So, whenever you find electric field or electric force, what you have to do? You have to place a unit positive charge. Now, due to this element, dq, what will happen? There will be an electric field at that point, which will be along this. It is a central force, right? Along the line joining the centers. Now, this electric field makes an angle how much more? Particularly opposite angle. This is phi, this is phi. So what it will be? This is small de, I will take it. Why? It is due to the small element. So electric field due to the small element dl is d. It makes an angle. So you can dissolve this de into two components. De cos phi one component, de sin phi another component. So the electric field will have two components. One is along x-axis and another along y-axis. So if I write this one in here, what you will write? dE can be written as vector, right? So it is dE cos phi I cap minus dE sin phi j cap. Why minus? dE sin phi is along negative y-axis, correct? So with respect to the direction ahead. What is dE? Small magnitude. We know that it is k dq by. What is the distance here? Let me take this distance as r. Clear? The distance I am taking it as what? R. So it will be r square. Now what is r from this? Now you substitute it, then we will see. So dE will be good. K dq, what you can write? dq is lambda dl, right? So lambda dl by r square. Substitute this value. K lambda dl by r square cos phi I cap minus k lambda dl by r square sin phi j cap. Now I want a net electric field due to this entire line. So I have to go for integration, but when I go for integration, everything is variable. Cos phi is variable, dl is variable. dl can be for anywhere, right? And r is also variable. So what I have to do, if I have to go for integration, I need to convert all the variables in terms of one single variable. Getting it, ma? So one single variable I need. So for that, what I am doing it, I will choose phi. Okay, when I take phi, first thing is what? Cos phi you find. Okay, I will change the color. So here what it will be? Cos phi will be equal to how much? It is A by R, correct? So now what is R, Kanna? It is A by cos phi. which is A secant phi. Any doubt? Tell me. The next thing is what? You take tan phi. Tan phi is what? It is L by A. Correct? So L equal to A tan phi. I need DL. In this expression, what it is? R I found it. DL I need to find it. So DL will be equal to A secant square phi. Correct? Into D phi. Tan phi differentiation is secant square phi d phi. Correct? Everything in terms of phi we got it. Now you go back to the expression and substitute it. So what is the DE? K lambda. DL is written as what? A secant square phi d phi. Cos phi I will write it as it is. Divided by R square. What I can write now? A square secant square phi. Similarly here also K lambda A secant square phi d phi divided by A secant square A square secant square phi into sin phi j cap. Without phi, write the unit vectors also. Now secant square phi cancels. 1a will cancel in both the terms. So K lambda by A. Okay. Here cos phi d phi into I cap minus K lambda by A sin phi d phi j cap. Till here any doubt? Next, we can go for differentiation because all the values K lambda A all are constant. Cos phi d phi we can arrange into integration. So what it is? Integration of dE K lambda A cos phi d phi.
Mama, can you go a bit slower?
Okay. K lambda A by. Till here is it clear?
Yes, ma'am.
Okay. So K lambda by A cos phi d phi I cap. K lambda by A integral sin phi d phi j cap. Is this step clear? Now what it is? Cos phi. Integration of cos phi is what? Plus sin phi. And integration of sin phi is what? Minus cos phi. But from where to where we are integrating? That we need to check now. So what is the limit of the integration? As I mentioned, come back here. See, the phi can vary between what? It can take, if you go this way, it is alpha, correct? If you come this way, it is beta. So this one, what did I say? If you measure it anti-clockwise, I have taken it as negative. This clockwise, I have taken it as positive. So the limits vary from what? The upper limit is alpha, lower limit is minus beta because we are changing the direction, right? So it is minus beta. Clear, ma? With respect to the reference line, we are measuring it. With the perpendicular line, if you measure it upwards, it is positive. If you measure it downwards, it is negative. So what is the limit here? I will specify here. It is minus beta to alpha. Clear? While substituting, what we will do, ma? Always upper limit minus lower limit, right? So here K lambda by A, I will take it outside. First limit is sin alpha minus sin of minus beta. Okay. Minus of minus plus, I will take it outside. So K lambda by A cos phi, that is cos alpha minus cos of minus beta. Clear? We know that sin of minus theta is minus sin theta. Cos of minus theta is cos theta only. Fourth quadrant, right? So the first term becomes what? K lambda by A sin alpha plus sin beta into I cap. I forgot to write I cap and j cap here. Write it. Plus K lambda by A cos alpha minus cos beta j cap. This is my E net. So E has two components. One is perpendicular component. Another one is parallel. Why? This is my rod I have taken. Correct? So this point for the point P, this is my perpendicular component, I will say. Along the x-axis, that is perpendicular component. Along the y-axis, this is parallel component. Along the length of the rod. This is perpendicular to the length of the rod. So, two components. Always keep this in mind. For the specific case, you apply the angle, find out the answer. That will be easy. Okay. Done? Now, next is what? Okay. Now I will show you because we need the reference, right? So, first thing is what? This is my rod and this is my point P. Okay. So, the direction of this is what? Here this is A I have taken and this is alpha, this is beta means. Here this is the electric field, two components. The net electric field is this way. What is the component? Perpendicular and parallel. Hope you remember this. Now first case is what, ma? When P is at midpoint. Okay. When P is at bisector. Along the line or on the bisector. So what it will be? Here you can do the formula method also or you can apply the concept also. See, it is a perpendicular bisector means both the ways alpha must be equal to beta, ma. For the finite rod, when I take midpoint, that means this alpha must be equal to beta, correct? So what will happen? Here, if you just solve this, the electric field will be what? You will get due to this and you will get the electric field. And here if you take one element, due to that the electric field will be this way, correct? D. But when you resolve this into two components, correct? You will get what? DE cos alpha, DE cos beta, correct? And here DE sin alpha, DE sin beta. But since alpha is equal to beta, what you will get? Sin components cancels, correct? Sin components will cancel out. Only cos components gets added. That is one way of thinking. But already we have done everything, right? So we need not worry about it. What you have to do here, instead of doing all these things, you know that the parallel components cancel out. There is one component, electric field has two components, right? What it is, if I redraw the diagram in this way, what it will be? So here the point P is here. So what is it? For this point P, we have one is E perpendicular, another one is E parallel, correct? So E parallel will not be there because equal and opposite cancels out. So only perpendicular component will be there. So E net will be equal to what, ma? K lambda by A sin alpha plus sin beta. Sin alpha is equal to sin beta. So you can just substitute it 2 sin alpha or 2 sin beta, you will get it. Clear? Any doubt? Next is what? When for infinite rod, when the rod is infinite, when the linear charge distribution is infinite. That time I already explained, you know, just take the wall, you sit on the floor, keep the pen horizontal way, mark this height, then just change the angle of the pen. For each time you mark the high angle, okay, by the time you just target this ceiling, almost you can see that pen is parallel to this wall. Okay, that shows what? When the infinite distance, the angle, okay, the point P will be parallel to that. Okay, that means what it is? It will make 90 degree. Alpha will be equal to what? This is your infinite charge distribution. So here if you take point P, what is that mark? This will be almost like this, correct? So what is the angle here? It is 90 degree. So alpha is 90 degree, beta is 90 degree, correct? So what is that? E will be equal to K lambda by A. If you are not comfortable with concept, directly go with the formula. Sin 90 plus sin 90, correct? Plus K lambda by A cos 90 minus cos 90 into J cap, this is I cap. So this is 2K lambda by A I cap, and cos 90 is 0, so there will not be any component along y axis. Parallel component is only perpendicular component will be there. So 2 lambda by 4 pi epsilon naught A into I cap. So this will be lambda by 2 pi epsilon naught A into I cap. This will be for infinite rod. Some of the things you should remember so that in exam it will help you in solving the sums quickly. Okay. Till here clear? Next is what? Semi-infinite rod. Semi-infinite means what? One end you hold it. The other end you don't know where it is. Okay. It is very length. So what it is, if I take, this is my end which I know. This is infinite. Okay. Now at one end of the, which end we know, from that the point P is perpendicular from one end of the conductor. So what is the perpendicular distance? As usual it is, we will take it as A. So what is the angle alpha kanna here? Alpha is 90 degree, right? But beta where it is? Harini, Dhriti, Vishwanath. Okay. So beta what it is? Beta is 0, no? Because we have taken exactly at the end of the conductor. So beta is 0. So what will be the electric field, ma? If you talk about electric field will again be in this direction. So one will be perpendicular component, another one is parallel component. We are going to find it out. Okay. So what will be the thing? Here E will be equal to K lambda by A sin pi by 2 sin 90 plus sin 0 I cap plus K lambda by A cos 90 minus cos 0 J cap. So sin 90 is 1. So K lambda by A into I cap plus K lambda by A into minus 1 J cap. Correct? Cos minus cos 0 is minus. So K lambda by A, if you take it outside, I cap minus J cap, this is E vector. If I want magnitude, what it will be, ma? It is magnitude of net electric field is K lambda by A under root 1 square plus 1 square, right? Minus 1 square. So root 2 K lambda by A. If you further simplify, root 2 by 4 pi epsilon naught A into lambda, which you will get it as what? 4. Root 2 you can write it as 4, you can write it as 2 into 2, which further you can write it as root 2 into root 2, correct? So this will be 2 root 2 pi epsilon naught A. This formula you need. Is that clear? Either you keep it horizontal way or vertical way, one end from one end at a perpendicular distance, you will get this value. So we have done with infinite rod, semi-infinite rod, infinite rod. Along the axis of the rod and perpendicular to the axis of the rod, we have seen. Now, till here all the cases are clear. Now next is what? Rod only, but we are going to bend it in the form of R. Okay, linear charge distribution. Okay, but here we will bend this in such that it makes an angle alpha at the center of the arc. What is the radius of the arc? I will take it as R. It is a uniform charge distribution. So I can consider it as lambda is Q by length of the arc. Now we have to find out electric field at the center, or O you can say. For this, what I have to do? First, I will just bisect this R into two equal segments. Now symmetrically I got it, ma. Two symmetric, this one I got. What I will do? Here it is a continuous charge distribution. So I have to consider what? A small length element, because it is linear charge density, right? So dl I will take. Okay. For this, what is the charge? dq is the charge. Now what distance it is from the point O, we can measure it with the angle. Only the angle varies, right? So what is that? At an angle theta, let me take it a element dl. Okay, what is this angle? This is theta. So what is the angle? Okay, this one. For this is what? d theta. Correct? The small element makes d theta. Clear? So because of this, what will be the electric field at the point O? The electric field will be here. Small electric field. But look at this. What is the angle that it makes? If this is theta, this is also theta, ma. Harini, is that clear? This alpha, I will erase it. Later we can take it. Okay. This is the original diagram. They will give you what? This alpha, and you have to find out this. Later we can do. So if this is theta, this is also theta, kanna. So what it will be? This is dE cos theta. This will be dE sin theta. See, the reason for dividing into two equal parts, this one, symmetric one. The reason is what? Again, at the same angle theta, I will consider one more length element whose charge is dq, because it is uniform charge distribution, right? At the same angle theta, I will take. So what is this? This is d theta. So due to this, there will be an electric field which will be in this direction. If this is theta, this will also be theta. This means here dE cos theta again. Here dE sin theta. So dE sin theta components cancel and cos theta component adds up. So total electric field we need to find. So dE net will be equal to what? dE cos theta. Summation, right? Okay. But from where to where? We have to find it. We have to go for integration. Correct? So integration, when I first use substitute, we will see. What is dE? dE is K dq by small dq, right? Divided by, what is the distance I have taken? Radius is this one. So r square. But we all know that lambda is what? dq by dl, correct? So dE will be equal to k lambda dl by r square. What is dl, ma? Arc length is radius into theta, correct? This formula you people remember, no? Arc length formula is what? L equal to r theta, right? So radius into angle subtended at the center. So using that, if I write dE will be equal to k lambda r into d theta by r square. Any doubt? Stop me. So dE will be equal to 1r cancels, k lambda by r into d theta. So I can write here k lambda by r into d theta cos theta. Now look at these values. K lambda r, everything is constant. Only theta is variable, right? Theta also, when you take it, from where to where it will vary. The total angle is alpha. That I have divided into 2, correct? And this is my reference line, correct? This point is my reference line, correct? So from here theta I am measuring. So 0 to alpha by 2 only I can take. Because total angle is alpha means after bicycling this will become alpha by 2, this will become alpha. So 0 to alpha by 2, the limits changes, correct? So here what I will do, this is 0 to alpha by 2. Now take everything outside, k lambda by r if I take it outside. So integral cos theta d theta. Cos theta integration is what? Sin theta. And theta varies between what? 0 to alpha by 2. So here what it will be, ma? K lambda by r into sin alpha by 2. Clear? One minute. Again, when you talk about this range, no, I have done one mistake here. See. If I take this one from 0 to alpha by 2, this is correct. From here to here, 0 to alpha by 2 only. But I have taken the component forms in which I cancelled the sine component and I have taken cos component. That means whole angle I have considered. From this to this I have considered. Correct or no? So from this to this is alpha by 2 means this angle I need to measure it this way. So it will be minus alpha by 2. Correct? Is that clear? So this will be minus alpha by 2. So I need to change my limit. Okay. So if you take one element and if you find it, then it is correct. You have to multiply by 2 at the end. But now we have taken 2 elements and we cancelled the sin theta component already. So it will be minus alpha by 2 to plus alpha by 2. So this will be here? So k lambda by r sin alpha by 2 minus sin of minus alpha by 2. So k lambda by r sin alpha by 2 plus sin alpha by 2, which will give me k lambda by r, 2k lambda by r into sin alpha by 2. Clear, ma? Further, if you want, you can simplify or you can leave it. What it will be? K value you need to substitute. 2 lambda by 4 pi epsilon naught r into sin alpha by 2, which can further be written as lambda by 2 pi epsilon naught into sin alpha by 2. This is due to what? This is r, right? Any doubt? In this also different cases we can see, right? First case is what? Semicircular ring. When I talk about semicircular ring, this is my reference line. If I take it, this is so this is my uniform. So at the center only we are finding the electric field, right? So now what will be the direction of the electric field? Here, when I talk about the angle is what, Kana? Here from this to this, alpha is what? Alpha is 180 degree, right? So this distance will be r, this is r, correct? Now already we have done sin theta components cancelled up, cos theta only will be there. So the net electric field is pointing downwards, correct? Any doubt in this? No, right? If you want, you can take one single element and draw here. The electric field will be this way. If you take this element this side, the electric field will be this way. So on solving, net electric field will be downwards, correct? I don't want to do again. Alpha is 180, that is alpha by 2 is 90 degree. That is pi by 2. Now E is nothing but lambda by 2 pi epsilon naught R into sine alpha by 2. So E will be equal to lambda by 2 pi epsilon naught R sine 90. Sine 90 is what? 1. So this value is what, ma? Due to the semicircular arc, it is 2 pi epsilon naught R. For J and all, just be thorough with the formula. And when you concentrate here, the same thing we will do it in the magnetic effects of current. Okay, electric field here, magnetic field there. So it will be easy for you if you understand the concepts. The concepts I am teaching you so that if you get stuck anywhere, you can just derive it. Okay, application oriented. Yeah. But you should remember so that you can save some time. Now what it is? Next is suppose the ring I cut it into only quarter. This one. So at the center I am going to find it out immediately. Where will be the electric field? Now you know that whenever we find that, this is the electric field direction. Any doubt? Yours. So what is the angle alpha? Alpha here is pi by 2. So alpha by 2 is pi by 4. Correct? Find out as usual. E equal to lambda by 2 pi epsilon naught R sine of pi by 4. That is lambda by 2 root 2 pi epsilon naught R. Sine pi by 4 is what? 1 by root 2, right? Any doubt? Okay. So non-distribution I need to teach you. Just a minute. I will open some book and I will give you some questions. Any doubt, you tell me. Now you do this sum based on this. One more thing in the infinite rod I forgot to teach you, that I will do it now because that is also important. Okay. Suppose infinite rod I forgot now. Just take it. Okay. Semi-infinite rod. So semi-infinite rod, when I take it, if the point is somewhere below this. Okay. This is the end I know. Okay. This end I don't know. From this itself, the point P is somewhere here. So what you will do? We have to extend this line. Okay. The rod, just extend it so that I can find the perpendicular distance. Perpendicular distance is very important. Correct? From there only we measure the angle. So this one we have to extend and you find it. Clear? The next thing is what? We need to measure the alpha and beta. Since it is a finite, infinite rod, so alpha is obviously what now? It will be parallel to this. Correct? Now, what is beta? That is the point in consideration. For beta, what you have to do? You need to find out this angle. Is this beta, ma? Usually they will give you this angle. But is this beta, you tell me? This is not beta, right? With respect to the perpendicular distance, that we consider it as a reference line. We measure alpha upwards, we measure beta downwards, correct? So for alpha measuring, what it is, that's why I am using different color. So from the reference line, that is perpendicular distance line, this is my alpha, correct? Now, what is that beta I have to find? It means from the reference line I am taking anti-clockwise direction till here I need to find it. Correct or no? So what is this angle will be 2 pi minus theta. If the theta is given here, 2 pi minus theta. Or simply you can take it as what? Minus theta also possible, but 2 pi minus. Clear? Any doubt? So further what you can write, alpha here is what? 90 degree or pi by 2, correct? So beta is 2 pi minus theta. What is the value of E electric field then? Electric field will be equal to semi-infinite, what it is not? 2k lambda by A sin 90 plus sin 2 pi minus theta I cap, then again k lambda by A, not 2k lambda by A, k lambda by A only. Okay, cos 90 minus cos 2 pi minus theta into j cap, correct? So E will be equal to k lambda by A, sin 90 is 1 minus sin theta into j cap. Sin 2 pi minus theta is what? Fourth quadrant, okay? Which can be written as minus sin theta. Now plus k lambda by A, cos 90 is 0 minus cos minus theta is cos theta only because 4 quadrant. So using this, don't need to simplify till here also. I just teach you the concept, okay? Don't do all this stuff. You directly find the value, substitute it and find the value. That's all. That will save your time. Clear, ma? Till here any doubt you tell me. Now based on that some questions we will see. Now do this one. Based on what we have seen now, you can use the same thing, find the value, okay? Is it readable? Do this.